weird connection number 3, the plane with the insect brain. When robotics engineer Dario Floriano was a boy, his mother told him not to fly his model planes in the house. Clearly, he didn't listen. Now Dr. Floriano heads up the robot lab at the Federal Polytechnic of Lausanne, Switzerland. He took the earlier research we showed you that revealed the exact motion of the fly's wings and will now attempt to build an indoor fly robot, complete with a brain that reacts as if it were a fruit fly.
For me, definitely the microflyer, when you see it moving around, especially knowing what goes inside the brain, so to speak, of these robots, is almost like a living device.
Science has already created unmanned flying machines called UAVs, used by the military for reconnaissance and surveillance. But they're large machines, made for the great outdoors.
There are many types of autonomous flying robots today, but most of those robots fly outside. So what we decided to do was to try to achieve or to design an autonomous robot that can fly indoor. Biology is an incredible source of information for us. Animals have evolved over millions of years to solve very difficult problems, and they did so very often with very simple solutions. So for us, it's quite interesting to go and to look at the fly, for example, or the fruit fly.
To make his fly-inspired robot, Dr. Floriano had to replicate a fly's ability to avoid obstacles and control its flying speed.
Now, one of the hypotheses is that housefly use hairs to detect how fast they fly. And on the microflyer, we don't have hairs, but what we have is an anemometer, which is basically a passive propeller. As the microflyer flies, the propeller turns, and we can detect the velocity of the rotations.
Then there was the task of duplicating a fly's sense of vision. It uses thousands of lenses in its compound eyes.
The biological solutions are very robust and very efficient, but sometimes they are not optimal. There could be a pattern on the ceilings or on the floors or on the walls that tricks the microflyer into it. And this you can see very common when you see the housefly. Very often it just goes against a wall or against a window, and then it simply flies away.
This is where the research team tests the microflyer's ability to fly just like a fly. Floriano is connecting into the environment of shapes discovered for testing flies that was used in the earlier research we told you about.
So what you see around here is just a sort of virtual cinema, 360 degrees, that our microflyer can experience as it moves around. Just like the fly experiences a sort of IMAX, like a virtual cinema in Michael Dickinson's lab.
Watch the microflyer as it buzzes about. It was able to figure out its own route without the help of human controls, avoiding all obstacles, including the scientists.
It looks like it's alive, not only because it's autonomous, but because it has something like a brain of an insect. And if you think of that, I think it's quite amazing. It flies continuously and autonomously. Actually, we are quite pleased. I think it's flying slightly better than we thought, and we still have margin for a few sensors or for reducing the size.
Remember, this robot could someday go where no human can safely tread and do the work of a mechanical superhero.
The possible use of the technology is to deliver a swarm of these very tiny insectoids, if you like, in buildings to search, for example, for persons in case of a catastrophic event. You just throw a bunch of these small flying robots and they would go and explore the entire environment.
We've gone from fruit flies playing video games to airplanes